How to find that line? Let's understand that. Let's understand that. Now, let's say we have a data point. Let's say we have a data point like this. We have a data point like this. We have a data point like this. Okay, something like this. Okay, let's try to find the best fit line to this data set. It is only containing three data point. It is only containing three data point, and we have to find the best line that can fit this data set, that can fit this particular data set, which is having only 3 lines. Okay, which is having only 3 lines. We are going to start, we are going to start with a random line. Let's say this is what the line is. Let's say this is what the line, and we draw a random line in the whole space, and we got this line here. And we are going to check how bad this line is doing, first of all. Okay, we're going to check how bad this line is doing. Okay, so once you check that, how to check that? Calculate the distance between the data point and the line. Simply calculate the distance between the data point and the line like this. And let's move this line point a little bit here so that there is no overlapping. Something like here. Okay, so what I just did, the problem was that I have to find a line that can perfectly fit these three blue data points. And we started the solution by drawing a random line, and then we will check how bad this particular line is doing, how bad this particular line is doing. And in order to see how bad this line is doing, we calculate the error. And how to calculate the error? We are going to look at the distance between the data point and the line, or more specifically speaking, the length of the distance between the data point and the line. Okay, like this, and this. And we are going to say that, let's say we are going to add this. Let's say we take these lines and we're going to add these errors. Let's say this is let's say what, 8, not 8, let's say this is 6, this is 8, and this is 10, let's say. And just take the example. This is not a official values, this is just giving you a scenario here. This is just giving you the whole scenario of the algorithm, of an algorithm. Okay, so let's say 6 plus 8 plus 10. Okay, let me just calculate somewhere else. Let's say 6 plus 8 plus 10 comes out to be 18 plus 6, 24. Okay, it comes out to be 24 as an answer. So you got the error 1 as 24. Error 1 as 24. Now we're going to repeat the same process. Not exactly the same process. Forget that statement. Now we are going to move this particular line around. We're going to take this line and move this line around the whole space. Okay, we're going to move this line around. But how will we move it? We are going to move the line in such a way that reduces the error. Okay, or let me tell you again. We are going to move this line around and check whether we have reduced the error or not. Forget the the latter statement. What I'm saying here, that we are going to move the line around and check whether we are reducing the error or we are increasing the error. It's not like moving the line in such a way. There is no such a way. In such a way that error is reducing. No. What I'm saying, that we are going to move the line around and check whether we are reducing the error or we are increasing the error. Okay, let's say our machine moves the line here. So tell me, has it increased the error or decreased the error? I or D? Has it increased the error or decreased the error? Increase, increase, increase. Everyone is saying increase. So definitely this particular line, this particular movement of the line has increased the error, right? And let's say it became 16, 18, and let's say what, 20. Okay, like 30, let's say. Okay, so error 2 comes out to be, the error 2 comes out to be 16 plus 30 plus 18, so 46, 56, and 50, 4. Okay. For 46, 56, 64. Okay, so error 2 comes out to be 64 around. Okay, error 2 comes out to be around 64. Got it? Now we calculated the error and we came to know that we have increased the error this time. We came to know that we have increased the error. Now what we're going to do, we are going to move in the opposite direction where we have moved previously. Understand this very carefully. Very, very, very carefully. What, before the line was here, before the line was here, and when we move the line around and we move the line, let's say in this direction, okay, and then we saw that the error is increasing, then we are going to move in the opposite direction of that error, the previous error. So if I tell you more technically what is happening, that you first start your solution with the random line. First start the solution with the random line, any random line around the data set. Then calculate the error, see where the error is. Now you don't know whether, now the machine doesn't know whether it has to move up, down, right, left, or rotate. What it doesn't know, because machine doesn't know where it is going to reduce the error. Where it is going to reduce the error, because we all know that we have to reach a solution where the error is minimum. We have to reach a solution where the error is minimum. Okay, so basically when the line moves here, we saw that the error is increasing. Here the error becomes from 24 to 64. So when you move the line here, the error got increased. Then what machine is going to do, machine is going to come back and move in the opposite direction. That means it understands that if I move in this direction, it is increasing. That means I have to move in the opposite direction. Okay, and once we move in the opposite direction, the error got reduced. Right, the error got reduced here like this. Okay, the error got reduced, and once it got reduced, you got, let's say, 5, not 5, let's say you got here what, 3, 5, and 8. Let's say you got 3, 5, and 8. What was the total before? 24. Okay, and you got the error 3. Error 3 is 6, 3, 9, 17. You got 17 this time. You got 17 this time. Okay, so keep understanding what I'm saying here. You got 17 this time. Now in the same way, we are going to repeat the process again. Move the line in some direction, move the line in some direction, see whether you're increasing the error or decreasing the error. If increasing the error, move the line in the same direction. If decreasing the error, move the line in the opposite direction. So let's say the line moved here. Let's say the line moved here, or let's say the line becomes after moving this. Okay, let's say the line becomes this. Okay, now once the line becomes this, you're going to again, your line, before the line was here, understand this carefully, before the line was here, now the line is here, now the line is here. That means your error is reduced this time. That means your error is reduced, and if the error is reduced, then you have to move in the same direction again. Okay, and you move the same direction and you reach till this particular point. Okay, and that is a perfect fit. And reaching from this to this is actually a whole lot of step in between. Lot of error, lot of checking, lot of error, lot of checking is happening in between. Okay, so we continue doing the procedure again and again and again and again. And if we are decreasing the error, we move in the same direction. If we are increasing the error, we're going to move in the opposite direction and simply reach the perfect solution. Simply reach the perfect solution in the end. Just by keep repeating the process. Just keep repeating the process. You're going to reach the perfect solution in the end. Okay, so type repeat if you repeat the whole thing in again. Everyone, type repeat if you repeat the whole thing again. Type yes if you understood. Everyone? Understood? So, in a nutshell, what is happening, the things to remember here carefully, you have to things to remember here, that you want to start your solution with a random line. Then you want to check for the error, how bad that line is doing. And how to check it? By calculating the distance between the line and the data point. And then we're going to move the line in another direction and check whether the line, how bad the line is doing. If the error is increasing, I am going to move in the opposite direction, and if the error is decreasing, I am going to move in the same direction again. Okay, and keep repeating the process, keep repeating the process, keep repeating the process until you find the perfect fit. That means, in the background, when you train a model, the line is moving like this, like this, and this, and reach here. That is how in the background the whole line is moving. And the algorithm that I'm talking about is called as linear regression. The algorithm that I'm talking about is called as linear regression. This is how linear regression works. Okay, in a nutshell again. Okay, that is how the linear regression works. Okay, so you said that you understood. Keep the notes, the steps that I've told you, make sure you write it down in the notebook. It's a very important steps, and it is going to help you a lot to understand other algorithms also, and also to understand the machine learning as a whole one subject. Okay, like what happens actually. So these kind of steps are happens in the background, and all these steps are going to happen in just one line of code, or more specifically speaking, only 2 words. You have to just write 2 words, and your all these processes are going to be done. But we'll see that in the practical session later on. Okay, now tell me one thing, that whatever I'm telling you, can I say that I am doing nothing, I'm just minimizing the error? Yes or no? Type yes or no. I'm just minimizing the error here when I am moving the line. Yes or no? I'm trying to minimize the error. Tell me, how can I tell me probably what concept is being used here. Tell me probably what concept is being used here. If I say you have studied it already, try to relate by what you have studied. The concept is gradient descent. Now let's get back to gradient descent again. What I said, you know, from problem, you have to reach a solution by taking the tiny steps. Okay, so this is your problem. When you draw a random line, when you have a data set and you have to find a perfect line, then that is a problem with you. Now reaching, taking tiny steps to reach the solution is the gradient descent. To reach the solution is gradient descent. So just remember this here, that the minimizing the error part, the movement of the line part is done using gradient descent. The movement of the line part is done using gradient descent. Understood? Whatever the movement that you're seeing is done using gradient descent, and we'll talk about that in a very great detail later on. Right now we are not going to study it, but later on we're going to study that. So just remember this term, that minimizing the error implies gradient descent. To change your